This is Math 20. We're still in section 4.5 on scaling. So let's look at the next example. My friend Sharon has a family room with lots of heavy furniture, and she never seems to be satisfied with the arrangement. Each time she moves things around, her husband and friends all end up with sore backs, lifting all this heavy furniture. In order to help Sharon design the layout of her family room without, that's a typo there, without actually having to move the furniture, her husband and friends have come up with a scale drawing for the room and for each piece of furniture. Now Sharon can redesign the room at the kitchen table without bothering anybody. So we've got this original room, and we're saying that it measures 18 by 15 feet. 18 by, let's just kind of draw, that's a rectangle, just kind of draw a picture. 18 by 15 feet. Yeah, not very good. Okay, we'll call this 15, and we'll call this 18 feet. Okay, and the scale drawing is going to be on a piece of graph paper, and the graph paper, well, piece of graph paper, most pieces of graphic paper are the same size as just regular typing paper, 8.5 by 11. And what would be a good scale factor to use? Well, I don't know. So it's going to be us kind of figuring out what makes sense. I have 8.5 by 11 is my piece of paper, okay, and I'll lay it down horizontally. 8.5 by 11 inches, okay, and I've got 15 feet and 18 feet over here. So just to kind of think it through, you can't have 1 inch equals 1 foot, right? Because you've got 18 feet here, and you only have room for 11 over here. So you can't have 1 inch equals 1 foot. So maybe a good scale factor would be to have 1 inch represent a half a foot. So if there are 11 inches over here, and each, I'll take that back. Let me take that back. 1 each is going to represent 2 feet. 2 feet. 1 each, 1 inch, 2 feet. So if I have 11 inches here, then all the way across, if each one of them is 2 feet, then I can show up to 22 feet this way. We're just kind of brainstorming what makes sense. And then, of course, going this way, I'm going to use the same exact scale. 1 inch equals 2 feet, so I have 8.5 inches. So I've got 8.5 times 2 feet. That's 16 plus another one, 17 feet I can get up to that way. And that would be plenty large to go ahead and do this, this drawing of her living room. Now, what about the scale factor for the furniture? Well, you can't change scale factors because if all of a sudden you're going to shrink the furniture down even more, well, then it's not going to look appropriate for that size room. So whatever you scale on one aspect of the project, that you have to keep that scale for everything. So this would be what we would be doing to change the scale. And the other way to look at that is for every foot in her actual living room, it's going to be a half of an inch. If 1 inch is 2 feet, then 1 foot is a half inch. Okay. All right, let's take a look at the next example. Charlie paid $45.19 for 9 gallons of gas. $45.19 for 9 gallons. If Alan stops at the same station, how much can he expect to pay for 15 gallons? Well, there are lots of different ways to do this problem, and we're going to set up a proportion. Remember, this guy Charlie, he's spending $45.19 for 9 gallons. And if Alan comes along, how much can he expect to pay for 15 gallons? Well, what's going to go where? Well, the dollars are going to go on top. And the gallons, this is 9 gallons. The gallons are going to go on the bottom, 15 gallons. Okay, and I'll put an X in here, our favorite variable. So there's our proportion. And if we solve this and we do it in a nice top-down manner, we're going to use cross multiplication. So I'm going to multiply these two guys together. 9x is equal to these two guys multiplied together. 45.19 times 15. So I have 9x, and this is what your homework should look like. You set up a proportion and so on. And this proportion business is going to be on your final, so you need to know how to do it well. So on my calculator, and you would be allowed to use your calculator on a problem like this, I'm going to go ahead and multiply $45 and turn it on first, $45.19 times 15. So I get 67785. And now I'm going to divide both sides by 9 in order to find x. So let me just show that I'm doing that. 0.85 divided by 9. X is equal to, and I already have it sitting in my calculator, so I'm just divided by 9. And I get 75.3166. So now I'm ready to answer the question. And typically on word problems, you're going to go ahead and answer your question in a sentence. And this is money. So what would you say? Well, you'd probably round this up to 32 cents. Okay, so Alan would pay $75.32. Okay, good enough. So took the information and we set up a proportion. Let's go on with the last example. Claudine is a very smart shopper, and when comparing 2 packages of whole wheat pasta that she believes to be of the same quality, and the reason I say that is because sometimes we're willing to pay an extra price for something that's a better quality. But when comparing 2 packages of whole wheat pasta she believes to be of the same quality, she has to do some figuring to figure out which one's the best buy. Papa Penne's brand of pasta is $4.49 for a 4-pound package. And Mama Manicotti's brand of pasta is on sale for $5.89 for an 88-ounce package. Well, what a pain. They're both talking about dollars, but this guy's talking about pounds and this guy is talking about ounces. There's lots of different ways to do this problem, but what we want to do is we want to be able to compare apples and apples, or I should say pasta and pasta in this case. We want to get a unit price. So I think what I'll do is I'm going to look at Papa Penne's and I'm going to change those 4 pounds to ounces. And this is what I'm looking at. I got 4.494. 4 pounds for 4 pounds. Well, I know that there are 16 ounces in a pound, in 1 pound. So I'm going to multiply 4 times 16, and that means that Papa Penne's is $4.49 times 60, or over 64 ounces. $4.49 for 64 ounces. Well, what is that as a unit rate? I'm going to divide the bottom into the top. So I have 4.49 divided by 64, by 64, and I end up with 0.07, and we're talking about money, so, and I'm going to be rounding that off to the nearest penny, so 0.07 per ounce, okay, so basically 7 cents per ounce. All right, now let's get a unit price for Mama Manicotti's. So hers is $5.89 for 88 ounces. Let's get a unit price on that. We don't have to change it here because this guy was in pounds. We changed it to ounces. So this guy's already in ounces. So we're going to have $5.89 divided by 88, and we end up with 0.06693. Okay, so we'll round that off. 0.07. Well, how do you like that? For all intents and purposes, they're the same. But you'd never known that looking at the information the way that it was presented. Okay. These are referred to as unit rates, and that's what I'm talking about right here. Unit rates. This is the best way, this is the best means that we have in terms of comparing something. I really couldn't compare it the way it was here because this was in terms of pounds and this one was in terms of ounces. So anytime that you want a unit rate on something, you want your denominator to basically be a 1. So if somebody says to you, you can buy apples for $5 for 3 pounds, we of course would be interested in knowing what's the unit rate, how much is it for 1 pound, and all it amounts to is just taking the 5 and dividing it by 3 and getting a unit rate of 1.6, and we'll call this 1.67 per pound. Unit rates just always end up with a denominator of 1, and you get that by simply dividing the bottom into the top. And that's it. So I hope that helped.